Hi everyone, welcome back to Voice of Code. And in the last episode, we learned about how we can scaffold a microservice using the Kodevy init template. And in this episode, we are going deeper dive into that particular template, whatever it has provides us, the structure, the layers, and how things are interconnected with each other, how the dependency is flowing. And apart from that, we'll be going more into a particular concept that is extension function. So in this tutorial itself and in this template, in all the templates we are working on, I have used a concept that is extension function a really lot. So some time back ago, when I was into Android development using Kotlin, I there work on a really crazy particular framework thing that was extension function. So Kotlin has its own pure features of extension function and libraries. So I implemented those into C sharp. This is my own version of extension function in C sharp, and we are using a lot of it. This is a built-in feature in C sharp as well. Apart from that, we will be working on a real-world entity. So in this microservice template itself, we are working on a database agnostic feature. So that is, we can switch between multiple providers of a SQL database provider. And also we are using EF core as a ORM, that is object relational mapping. So we will be having our core first approach, where we will first write the code, then we will run the database migration on the Postgre database itself, and after that our database will be properly synced with the application. So this is, we are working on this, a user entity, real world entity, and how data flow works between all the layers, that is API, then application infra, and the domain layer. At the last, we'll be testing a set of APIs for a real world entity user. So in this case, we are working on user, and we'll see in our local host at Swagger how these works, and whether we are able to save the data in the database or not. So without any further ado, let's open the engine of each and every microservice template, and we'll look into more into the platform APIs. So guys, this is what we got from the microservice being scaffolded, and we have all the four layers: API, application, domain, and infra, followed by the organization, system, and microservice. This is the benefit of using this template, that we can just easily customize it, and we don't need to replace the naming convention from in each and every file actually. So before going further, let's just explain the concept of extension function, what they are, since I have used a lot here in this template as well as in the platform APIs. So let us understand by just using a simple example. So I'm just creating a class here as a test. This is just a file. So let's create a class name as demo. So inside demo, I'm just having a function that is named as run. That's it. Now I'm just creating another class, and that is just a simulation of just a main class. So public static void, sorry, not void, it's a class test main. And inside this class, I'm just having a function that is public static void main. So I'm just mimicking the functionality of main function. Inside this, I'm just creating a object of demo class. So demo obj equals to new demo. And the reason for the error is it's a function. So I can create the object of demo class, and I can just say object.run. That's it. Since this is the object of demo class, I can easily call this functionality. And if I want to extend functionality of demo class, I can simply enter a function here, or maybe introduce a new function. But what if when we have some classes which we cannot touch? So let's say program.cs, we have configure app. Let's go inside this class, or sorry, this function, and we have this add swagger configuration. In that case, the rider or the ID itself takes us to the decompiled version. That means this source code is available in NuGet, but we are only getting the compiled file, and we cannot edit it. And if we do it, it will not make any impact. See, we are not getting any error here, since the editor will always, or maybe the framework will always take the code from the NuGet itself. In that scenario, if we want to add some functionality, or that means adding a function to a particular class, if we want to do that, we have a one thing which we call as extension function. So in simple, extension functions means extend functionality of a class. That means adding one more function without touching its code base. Okay, so how we can do that? So let's say this is a class where we only have the IL code. That means its source code is not here. We are seeing the compiled code, right? If I want to do that, that means I just want that obj dot just one another function name, that is extended run. And right now it is not coming here since it's not a part of that demo class. So what we have to do is we have to create a static class. This will be the wrapper for holding all the functions. So I can say extensions demo. Inside this, I need to have a function. So public, it should be static. This is the first requirement. It should be static, whatever return type you want. And let's say extended run. And that's it. We are just one thing away from making it as an extension function. So right now, if you go here, you will see, still I will do obj dot. I am only able to see the run function. We are not able to see the this function. So the only thing we have to do is we have to introduce the first parameter followed by this keyword as the class name. That's it. Now if I go here, I can say extended run. That means any function that is static and having the first parameter as the class name itself followed by this keyword becomes the function of that particular class. In reality, it is not in code wise. See, we don't have that second function, but as a conceptual thing, we can extend the functionality using this particular approach. If I just change the class name from here, string, see, now it is no longer available in the demo class. It is available in the string class. So I can say var name equal to, sorry, var name equal to Vijay. Now it's a string class object name dot extended run. Okay, minus Vijay. Now I can say name dot extended run. See, now it has become the extension function on string class. If I change the first parameter type, it becomes the extension function of that particular class. So this is how extension function behaves. And if now my question is pause this video for 30 seconds or maybe more than that and think of that what is the class name that we should replace with the first parameter of any static function followed by this keyword so that it becomes extension on every single class, whether libraries or custom defined. This we have to think of, since what I just said is whatever we provide here, any class, this function, the static function became the extension of that particular class. Now what should be the class name that we should provide here so that any function can become extension on any class, that is any libraries or custom defined. And if you will be able to hack this, that means you are now able to understand how extension function concept works in Kotlin and how I have implemented that in C#. So pause this video and think of it. Okay, so the simple thing is that let me show you one thing. See, okay, okay, right now this is the function on demo class. Let me do just one thing. So I can say public class child demo. Okay, so this is the child of demo class and I'm inheriting it from demo class. And I'm creating an object of child demo here. So where obj2 goes to new child demo. Okay. Now I can say obj2. That means the object of child demo class. obj2 dot extended run. See, this extension function is only the function over this demo class, but any child class of the parent class can access its function. Obviously, this is the core of inheritance. So the answer of this particular question which I have just asked is replace this with something that is the super mother of all classes. And in any object oriented language, that means the OOP system, object class is the superclass. Right now, this extended run function is available on each and of every object, whatever you create, whether it's already existing string, integer, float, or your custom defined like demo, child demo, authorization policies. If I'll just go here, I will just say, come back here. I can say authorization. Okay. Policies. My bad. Policies. obj3 equals to new authorization policies. See, this is something coming from, I mean, from so different perspective, since we are not talking about this thing, authorization policies, or maybe any class. Okay, let's consider this as authorization policy. Let's not make object of this. I think this is the static class. Yeah, this is static. We don't have any sort of user controller we have. Okay, let's create object of this particular thing, and we in this constructor we don't have to pass anything. So where obj3 equals to new user controller. That's it. See, now obj3 dot extended run. See, this function is available on each and every class since we have provided the first parameter as object, and that is the mother of all languages. Or sorry, not all languages, all classes. So this is extension function, and we have used a lot of it. So now I hope you have understood this particular concept. Let me just go through each and every layer and understand how it's working, how it's interconnected, what is the exact definition of each and every file present here, and then we can quickly go and walk and create APIs for a particular real world entity, that is the user entity. Okay, so let's start looking into each layer. So starting with the API layer, or let's do one thing, let's just start with the domain layer. So right now in the domain layer, we only have one thing, that is entities. And as I have told you, this is the core of clean architecture. So domain is something like that has no outgoing dependencies. That means it doesn't depend on anyone. It can just stand alone, and it in reality, or in short, it doesn't need anyone to stay alive. That's it. The only thing is that in this microservice template itself, this domain entity is basically dependent on one core domain entity that we are taking from the platform. So you can see kodevy.platform.domain.abstractions. So we are having a I auditable entity, and if we go here, see, we are just the ID is decompiling the code, and we have reached here where we can see decompiled with JetBrains Rider. That means it is basically a library. We are just seeing the source code but decompiled. So we have four things, and for this to work or show you guys, I have opened this platform project. So you can see in the domain we only have just one thing, abstractions, and we have IRO table entity, the same thing which we are seeing here. It's just that this is the project itself. So the reason for creating this is that so that every entity always have this created at, updated at, created by, and updated by. So these are the characteristic of basically an auditable entity that can be auditable. That means we can have audit of that particular entity. And as per our inheritance, if any class is basically extending any class or interface, it is actually having those properties. So now user is a auditable entity. So user is having all those fields. And then user have simple ID, email, name, and then a private constructor for EF core, and a public constructor having business rules. So these are the core logics which always stay in the domain, and this is basically the purpose of the clean architecture, that always the core logic should be in the domain so that we can quickly transport it without impacting other layers. Again, this is one of the core logic, and we can have more logic here in the domain itself. So now let's go upwards. So this is the only thing, and domain, if you can see from here, I'll be able to replicate it for all the layers, but you can see it is vice versa for each and every layer. So if you go to each and every layer C# project, you can see it is referencing to its core project, that is the platform domain and platform project itself. Now let's talk about the infra layer. So infra layer is basically, it works on two things. That means the repository. So repository is something that will deal with the databases. It will be having the context and how to save the data in the database. So right now the repository contains the app.db context and is inheriting or basically providing an interface so that other layers can talk with this. So application layer is talking with this using this interface, and it has all the implementation so that in future we can just have one more implementation. If I don't want this implementation, I can just have like MongoDB user repository, and in that case I just need to inherit or implement this interface. Then we have DB context. So wherever that particular repository is basically talking to, and in the DB context, we have all the DB sets and just one more thing, that is apply configuration from assembly. I will tell you what it is doing, but let me tell you just in short that this is basically scanning all the layers where we have app DB context, and whatever that DB context has the DB set. So it will scan all those things. Let's talk about the configuration. So configuration is basically the definition of a table, that how it should look like. So I am saying that we have a user configuration, that means for user entity, where we says that the table name will be users, the primary key will be ID, it will be having property this and these sort of validations. We can also put these validations in the domain itself, but since this is a database agnostic microservice we are working on, where database can be anything like MS SQL, SQL Server, PostgreSQL, MySQL. In that particular case, we are actually generating this configuration, and later on EF core will generate this based on the database provider we have. So we don't have to worry about the provider. We don't have to change the code as per the provider. We can just simply switch a key in the app settings and everything is good. So this is the core definition. So EF core will understand it and will translate it into based on whatever provider we are using. After that, we have this domain. Domain we have discussed already. Then we have this application layer. In application, we have some API clients. So if in case we want to talk to external APIs, we have this API client. Then we have all the configurations. So app configurations, application settings, and external services URL where we want to talk to. Then we have some contracts. So in contracts, we have repository, like whatever contract this particular application layer is having with other layers. So with infra layer, we have the user repository contact. And for services, this is actually defining the contract so that API layer can use it. Then we have DTOs. So entities transforming into DTOs so that we can actually transport that into more layers. We don't need to pass that complete entity if we want to not show some sensitive information to the client. Then mappers for those specific DTOs, and then we have the services implementation. So whatever contracts we have for the services, we have the implementation here and also the contract here, so that API layer can call it. So this is the implementation of the service itself. Let's talk about the API layer. So in the API layer, we have controllers. These are the core components that communicate with the client, that accept the request, that validate it, call the service interfaces, and let the service handle the stuff, and then get back to the client with the response. Then we have some extensions, services wire up. So services wire up is basically we have all our dependencies together actually plugged in. And then we have app settings, we have authorization policies. So let's say like later on we will be needing these stuff, since we will be implementing authorization and authentication. And at the end, we have this program.cs, the core, and this is the minimal program.cs, and it was achievable just because of the platform APIs. So as you can see, we are calling here create builder, then we are calling configure app. So configure app is, this class is basically an extension class. So builder extensions, that means all the functions here should be static, first thing, and will be going to an extension function over builder class. So web application class, builder is a class we have, and all the functions here are, if public, they are extension over this particular class. So as you can see, the return type is this, and the first argument is also this. That means it will be, this app function will be an extension function of this class and will also return the instance of that. So this is all the stuff we had, and then program.cs later on. Application also has all the extension functions. The web application, and you can see this is the extension over web application class. So for wait a second. For builder, what we are doing is basically we are actually building first our database configuration section. So in app setting.json, you can see we have this particular section, database configuration, which we are loading into a particular class, and that class is a part of the platform itself. See, this is the platform.infra.relational database. So we have a class that is representing the database configuration. So we are loading all the keys there. After that, we have the also extension function. So this extension function is over object class, which I have developed, and it is inside also the platform itself. So see, if we talk about T means generic, and generic means any sort of object. So all objects are basically the child of object class. So we are calling also, and then we are calling all the extension function. We have add controllers, API endpoint explorer. We have application configurations. Then we are checking if is not development, then just add the HSTS and configure the logging. So logging is also there in the platform APIs. We have the base Serilog, and we are also reading the configuration from the app setting.json for Serilog itself. Then we have configure dependencies. In dependencies, we have all the application layer dependencies. So if I talk about application layer dependencies, then it's also calling the base first. Sorry, not the base first. It is initializing its own dependency. So right now we have mapping profile, I user service, user service. And then we have the base. So always the base stuff is in the platform itself. See? base application layer dependencies. And if you can specifically want to look on here, you can see base application layer dependencies. This is the wire up. So this is again an extension function. That's why I just told you that we are heavily using extension function concept here. Then we have infra layer dependencies. So in infra, we have databases, and then we have relational database. We are adding the DB context. And this add relational database is again an extension function on the platform APIs itself. It is actually checking whether the provider is not there or not. So right now we only have two: SQL Server, PostgreSQL. If you just type there as MySQL, so it will throw an exception that MySQL DB provider is not implemented. So it is basically going to be or coming to be a feature on the next update on the platform APIs. Then we have the base authentication authorization, where we are just passing the authorization policies. We are passing the register method, that these are our policies, and implicitly the platform APIs is doing its own stuff. It is actually calling basically making the strategy. Then we have the authorization, how authorization will work out. Then we have the claims here. Apart from that, we have the Swagger configuration. So this is again a platform API. So we are adding Swagger Gen. Then we have this Swagger Gen options. You can see these are the Swagger Gen options. Yeah, this one. So you will be able to see this once we will run this application. I think in the previous episode, you have also seen that if his authorization is enabled, it will say this application uses JWT token authentication. Otherwise, it will say this application is not secured by authentication. And right now, it is not actually enabled. So if I go here in the development, enable authorization is false. So this is the key where all this stuff depend. So this is how platform APIs, Kodevy platform APIs are helping us. Apart from that, we have application CORS. So it is also reading from the configuration. So we have the CORS policy. Then we have some CORS options. And in the development, you can see here, we have these are the allowed CORS origins. So we are just allowing right now the 4000 port. Then we have the shared health checks. So we have also health checking here as well. So we are adding it here. See, we are checking for database as well as each and everything. This is the main purpose of the web application builder itself. Then we are checking whether it should be run or not. So the reason for that, this is in development, we are actually enabling the migration by default. That means in each and every run, your pending migration will running on the database. And I will show you how it will run actually. But in production, what we are doing is we are actually not allowing that particular feature, that and we are actually letting that we have to implicitly enable one key in while running the application, that is run migrations only. And when this flag is true, it will only run the migration, and this application will exit immediately. And after that, we have to run this application again after migrations applied using this flag set to false. So that's the reason this is the check here. If it should not run, then process will exit here. Otherwise, it will go further. We'll configure the middleware. So we have application setting. We are loading that from the app settings. We have global exception handlers. Then we are checking if this is not development. We are using HSTS. Then we are using the CORS here. So use app CORS. So we have the default CORS policy. Then we are using these two middlewares like authentication authorization. So these are for .NET authentication authorization. Then we are checking if enable Swagger UI is true in the application settings. We are enabling the Swagger UI, mapping the controller requiring authorization. If this is enable authorization, otherwise just do it normally. We don't require any authentication on the route itself. After that, we have just configure endpoints. This is another extension function. So then we are mapping these health routes. So we have one route as health live and health ready, and then just a basic route as health, which can be accessed by anyone. Or basically these three routes can be accessed by anyone, since we have the check as allow anonymous. As you can see, extension function also helps in, like, if we always return the instance of that particular class, then we can also chain those functions. See, this configure endpoint is basically can be called over the object of web application builder, right? Web application. And configure middleware is actually a function over that particular class, and also returning that. See, it is returning app. And what app is? App is also a web application. So when we do such sort of thing, this is called chaining, or basically function chaining. We have method chaining. So this is our complete how our application looks like. This is how it is utilizing stuff from Kodevy platform APIs. And this is how we are actually minimizing the things on our end so that we can focus only on the business logic. See, we have a lot of stuff here. We have this core, Serilog, base stuff, which we can directly control from the app settings. So that is why Kodevy platform exists. It is actually abstracting all the basic information from the microservice itself, the first thing. And second thing, all microservice don't need to really do these sort of stuff, and the API is providing all of this under the hood with just a one basic line away. So and that is importing those. Now we will just work on this user entity, and we already have this. We already have this thing here. Just one route, that is the registration route. We can work on this, and we can also create more routes which will return the data, by ID. So we will see on it. So before creating another set of APIs, we already have a real world user entity that is already been shipped with the microservice template. Let's just run this application. We have also done that in the last episode, and let's see uh, if the first API works or not. So we have this Swagger UI here in front of you and in front of us as well. And let's try this out, this register API. So we don't need to send the ID. We can just send the email. And there's something wrong with this API. So it says 500. And we have also checked that in the last episode that it says relation user does not exist. Now, I have already told you we are using EF core. So that is the code first approach. So code first approach means first we will define our entities here. Then once this application will run, what it will do, it will pick the configuration from here. So this is the user configuration. And the reason for picking this is since we have applied this apply configuration from assembly. So it will always check any files where it will find this identity type configuration of any specific class, and it will create this configuration. But the migration is not running here. We have to specifically run the migration. And once we will create the migration, only after that, this application will automatically apply the migration to the in the development mode. Okay. But so applying is automatic in development. In production, we have to manually trigger the migration application basically based on a flag. But in development, it is automatic. But we have to always create the migration. So for migration creation, what we will do, we'll just go to the file system and we will say, we will like refer to this readme.md. Okay. So let's refer to this part, and it says database migration. So it says first we have to give the permission to this add migration.sh if you are in Linux, and if you are in Windows, you have to run the PowerShell command, not the shell command. So right now I'm in Mac. I just have to do this. So I will say this. Okay, no such file or directory. That means this file is somewhere else. So I have to first check whether this file exists here or not. Okay, this file is here. And what's wrong with this? Add migration.sh. Done. Okay. The issue was with this commenting itself. And now I have to do one thing. So I have to do like add, that means executing this script, the PowerShell script or the shell script. I am using the shell script, and I have to name the migration. So like add user table. So right now we didn't do anything, and we are generating the migration for this user table. So what we did, let's suppose we add this user table. Now migration means that whatever we have done in the code, name of that specific event which we want to add in the database. So let's say you have updated a column, you have removed a column. So what you did, you have to name the migration. So in that case, we have just added the user table. It is not there completely in the database. For the database, it will be an add user table event. So I will say add user, sorry, not here. I will say add user table. This is my migration. And when as soon as I will run this script, okay, it says permission denied. Okay, so it was some specific Mac issue, and figured that out. So let's run this script again. So add migration.sh and the migration name. And you'll be able to see that it has started the build, has succeeded the build and done. Now, after this script has done its work, you will be able to see a folder here that is migrations in the infra layer itself. So we have just one migration, and inside the migration, this is just a step like how this application will write to the database, what it will do after connecting to the database. So it will create a table, and it will also apply these constraints. And then we have the snapshot. The snapshot is basically version of migration applied on the database. So let's say today you have like created this migration, and you didn't apply that, or you applied that on one development database, but in production this is not applied. So this snapshot will keep keep the track of this, and what it will do, it will just create a extra table in the database named as snapshot. So this will contain the latest migration applied on that particular DB. Okay, now these migrations are done. Okay, now that means once I will up this application again, our database will have the users table. Let's first connect to that particular database. Okay, so we can see from the console itself that the migration has been applied. So you can see from here, these are the migrations. Okay, and also there's a migration history that has been inserted into the EF migration history table. That's how it keeps tracks. And now we have to go to this database, and we have to run this query here. And we can see we have this users here. We have two tables, schema is public, and we have two tables, EF migration history and EF, and also the users table. So we can just do one thing. So you can see we have this query select star from users, and we don't have any record here. But right now we have our table ready. That means we will not get that error again, and that is just because of we have created the migrations in the domain layer, sorry, infra layer. And since our database keep tracks of a table that contains the latest migration, it checks that okay, this migration has not been applied yet, and in each and every bootstrap of the application, it will apply the pending migrations. Now we can get back and we will see. Let's rerun this application. Okay, it's already running. We can now just do one thing. So let's try this register API now, and let's remove this. Then we have email. So developers.javalogist@gmail.com. We have the name. Done. And just leave all the field as it is, and we'll execute it. And we got the 201 response. That means content created along with the response body as true, user created successfully, and all of this stuff. So let's check the database once, and we also have the logs here. And you can see we have one row here. So that means our DB is working fine. We are able to connect to the database from the application itself, and we are able to just insert a record. And you will see from the domain, from the entity, we have all the fields. So created, updated, created by, updated by. That means these are automatically populated as this logic is not in the entity. This is being provided by the platform APIs. Now it's working fine. So what we will do, we will create one set of API, or basically two APIs, that will fetch first about the total number of users there, and second one will fetch based on the ID. So let's do it. So we are here in the user repository, and we can see we already have get by ID, we already have get by email. Okay, so in repository this functionality already exists. So let us add just one more functionality, and that will be get all. Okay, so it will be just a task. Let's just stop this first. So task of list of users, since get all is basically now, instead of list we will be using IEnumerable. So it will save the space in the memory, and we will say get all async. Done. Let's go to the repository implementation, and let's implement this. We'll implement the missing members, and it's really simple. So we will say, and if you, this is basically one liner. So what we will do, we will just use this one liner function. It, it will be having context dot users dot as no tracking. This is really important. Dot to list async feature here, this functionality. Okay, and there's something wrong. Okay, so it's basically the difference between task and all, and we need to put the sync here. Method has overload with cancellation support. So it says that this particular method has one more overload that has cancellation token support. So we have the methods here. Now let's go to the service. So interface is having all the methods. We'll go to the application layer now. And in this user service, I'll create one more function. So that is, so let's go to the iUser service first. We have create, we have get you by user async, and we have the user ID. Let's create one overload function here. That means overload means name will be the same, but task will be different. So it will return, it's basically wrong. It should be just one user. I mean, from an ID, we can only have just one user, and also from the email. If we want to make it just, so it says string email and cancellation token CT equal to default. Okay. Uh, just name it the same, get by user thing. So now we have two overload here. The reason for overloading is that we only have the parameter difference, rest they are doing the same thing, just returning the user DTO. Go to user service and just change it from list to user. That's it. So now it says get by ID DTO equal to map of just the single user. So we are just mapping the entity to the DTO itself, and that's it. Okay, we are just returning the response wrapper here, but here we are not doing the same. So let's do it. And also we have one more overload. So first implement that. And let's just change this. So I'll let you know about this later on. This is a service response wrapper. I have created this wrapper. So this is basically a pure class. That means it will be a class that will be representing response from the service class or service layer itself, so that the API layer can understand it and properly format or basically transform that response into a proper API response. So let's do the same here as well. And we already have some helpful function there, service response. So service response wrapper, this is basically a generic class. We have to provide what we are returning here, user DTO. If we want to do that, dot success, and we can just pass the user DTO, and then we can say, so user DTO we are passing because the type T here is user DTO, and we can say the message is user with ID, and let's put make the string interpolate, and the ID is basically user ID. Fetch successfully. Makes sense. Something is wrong. Just leave that. What's wrong here? Let's check this. Cannot convert type DTO to return type. Application.dtos. What is the DTO? Okay, so the return type is not same here, so we have to change it as DTO or maybe user DTO. Not maybe, exactly user DTO. Okay, and we'll go back here and we'll also change this. So get by user, it will be a service response wrapper of user DTO. DTO. This is the wrong import, and will be same for this as well. So always the service will return the service response wrapper as per what I prefer. Okay, let's come here and let's also change this from this to this. This is basically get by user async. Get by user async. We have two overloads. We will create one more. So that is get all. So we will say task of service response wrapper of list of user DTO. Get all user async. We'll implement that as well. And here I will just say return, or I can just say where user equal to first get that user. So await repository or user repository dot get by email sync, then just convert it to user DTO equal to, let the mapper do the mapping, and then return service response wrapper of user DTO. That says okay, it's an auto completion feature. That's now let's fetch the users where user is equal to await user repository dot get all async, pass the cancellation token, the name is CT here, then map these and just return service response wrapper list of user DTO. Okay, dot success. User DTOs, comma, all users fetched successfully, and let the error be the same. I will make it go away. So first of all, we have to make this function async, as this is using just await, and now we just have this issues only, right? Okay, we have all the functionality here throughout the service. Okay, service is communicating with the repository, so it has the two dependencies, I user repository and just IMapper. Now we have to create the route in the API layer, so let's just do that. So controllers, we'll just copy paste this. Okay, and let's create a route of HTTP GET. So we are not using this template register. This is just the basic route HTTP GET. We don't have anything, and it says get all. Now I'll say okay. Just remove that. Where all users equals to await whatever the service is, service dot get all async. We need to pass the cancellation token. We don't have to do that. We already have the default parameter for that. And we can say return. So all users is basically a service response wrapper type. So we can call this to HTTP result function. This is again an extension function. And the reason for that is it is internally doing all the stuff, checking the status, then actually setting the HTTP result and calling even the on success or whatever we are passing. So right now the success is true. So it will say to HTTP result. And in this case, we have to pass the controller itself from where we are calling this. And for the body, we have to pass a lambda. And it's basically 200. So we can say, okay, since we are just getting the body, that's it. What's wrong with this? Okay, we have to pass. No. Okay, this is not an error. This is just a suggestion that we have to convert it into a method group, but we don't have to do that. So we are all good. Right now, we are saying that to HTTP result, that means if the status code is success, so it's checking the service.status success. And if that is success, it is just calling the on success callback, whatever we are passing. And inside the on success, we are calling that, okay, just send this 200 status code along with this body. And the body is this. So it will always have the structure. This is the HTTP result. That's it. Now let's go here and run this, and we'll fetch all the users. Let's refresh it, and we have the API as API/user. That means this is the get API. We don't have to do anything here and just execute it. And it says 200. Okay, request as method cannot have a body. Why it has a body already? Okay, it's something wrong with the definition itself. So we have to change it. We don't want the body here. We have just ignored that. Just a copy paste. So apply changes, and let's try to refresh this. Okay, we have to restart it, and it will all again cause the issue, the same one. And now we can have hit this API, try it out, and just execute. And you can see we have this success true message, all users fetched successfully. The data is the users itself. So we have the one user which we have created and everything. So this is basically our response structure. And this API response extension function is basically doing all this particular thing. So it is basically converting the service response wrapper to this API response wrapper, and we are returning basically a proper response. So we have this API response. If we go further, we can see this is the response. We are having a structured response. And if any error occurs, any exception occur, we also have a global exceptional handler that is there registered as well. We can have in the middleware. So we have this global exceptional handler, global exception middleware, this one. And this is basically also returning the API response object. So in any scenario, whatever the status code will be, this microservice will always return a structured object. And this is basically what I really wanted to achieve, that I don't want the front end to handle all of a JSON. I mean, structuring it or maybe just guessing that, okay, this time this particular thing will not come. So this is properly OOPS based style. Now rest of the thing you guys can implement. I mean, you can always have more endpoints here with this approach. If you want to return some other stuff, like you can always see here. And the benefit of this particular function is that it will always check the service outcomes. You just have to set the service outcome. If it's a validation error, you can set that. So let's see. Let me show you where we can have that. So we can have that in a particular thing. Let's suppose this particular area. So we can check if user is null. That means the ID is wrong. Maybe that's why the user is null. So we can return service response wrapper of string, or basically null. We are just passing data as null. Let's just make it as string for now. Dot validation error. This is a validation error. User does not exist with whatever ID we have passed. So simple. We just have to do this stuff. And the controller, we don't have to change anything here. We just change our business logic and rules in the service layer. So that also contains our business logic. To HTTP result will always check itself. It will all figure out that, okay, the service outcome is right now validation error. So it will just say bad request. So instead of 200, you will get 401. Oh, sorry, 400. Right. So this is the benefit of this extension function which I have developed here, and to just make our controller layer neat and clean. So you guys can add more APIs here based on what you prefer on this user entity. And this is the real-time example of using a real entity here. So this was our first backend milestone from microservice template to running the microservice live. In the next episode, we will set up our micro frontend and the NX monorepo using Kodevy NX preset. Thanks for building along with me. I'll see you in the next one. Till then, keep watching and subscribe Voice of Code. Thank you.